I'm Tim Ventura, and we're joined today by Dr. Paavo Pylkkänen, university researcher in theoretical philosophy at the University of Helsinki and also at the University of Skövde, Sweden. He's known for his work on mind-body studies, building on David Bohm's interpretation of quantum mechanics, in particular, Bohm's view of the cosmos as an enfolding and unfolding whole, including mind and matter. So, Pavo, welcome. It is an honor to have you with us today. We're exploring some complex topics in consciousness. So, let me start out by asking what inspired you to get into consciousness research initially?
Well, it's a good question. I think I must have been in my kind of late teens. I got interested in philosophy, but also a kind of an Indian-born thinker, Krishnamurti, who was, of course, talking about consciousness in a way very different that I've encountered before. I mean, that was late 70s and early 80s, and then through Krishnamurti, I also came across David Bohm, and so I guess both of them were talking about consciousness. Krishnamurti more from this kind of meditation or philosophy of life perspective, and Bohm also from the natural science perspective. And later on, I moved on to philosophy. Of course, it's an old topic discussed there, and also with like cognitive neuroscience, and eventually, I think in the 1990s, it became quite a big topic in also like in the academia.
Well, I understand that in addition to your own research into consciousness, you've also initiated a consciousness studies program at the University of Skövde. So can you tell me a little bit about that program and how it's helping students?
Well, yeah, well, that was it. I mean, what happened with me, I mean, I did my master's in the UK, the University of Sussex, the mid-80s. And then I came to Helsinki, but also interacting a lot in the UK, in the University of London and then finally, when I finished my PhD and a postdoc, there was an opportunity I got a kind of lectureship in University of Skövde in Sweden. So it was a small new university, but there was an opportunity to start a new bachelor's program, and so we ended up actually launching. It may well be the first like a bachelor's program in consciousness studies at the university level, where we had philosophy and cognitive neuroscience, and the program is still there, and it's going rather well. Although I have myself been in recent years more based in Helsinki.
Okay. Well, so I want to get into David Bohm's work because this plays such a tremendous role, I guess, in your research. You knew him, you collaborated with him in the 1980s and early 1990s. You've also collaborated since the early 90s with physicist Basil Hiley, who's a close coworker of David Bohm for over 30 years. What was it like working with Bohm and Hiley? And what were some of the concepts that you developed together?
Well, yes, it's interesting because, of course, I think I first met Bohm. It was in 1980. So really, I was like in my early 20s, and he was much older by then. So he could have like been my grandfather in terms of age. So of course it was, it took some while to really sort of get to know him more, but anyway, I was very interested in his work and would meet him from time to time. There was this school at Brockwood Park where Bohm was active, where also Krishnamurti was active, and I spent some time there. And I guess gradually then, of course, initially the primary interest was more in questions like, the nature of thought, consciousness, also human transformation dialogue. But I also got more and more interested in philosophy of physics and philosophy of quantum mechanics. So I'm not a physicist, but somehow there was the opportunity to discuss a lot with Bohm, and he had a very broad field in which he would be thinking. So he would go beyond quantum mechanics into biology, neuroscience, consciousness, also religion and art. I mean, it was quite an amazing scope. But anyway, so what we ended up doing, I think it was like maybe in like mid 1980s, when I was at Sussex first, and then in Helsinki, but also in London. And so I guess with Bohm, our discussions focus quite a lot in general philosophical questions like the relation between knowledge and reality, or thought and reality. Bohm had rather interesting ideas over there, and I guess I was also trying to challenge him a little bit there, because I was doing my PhD at the time, and so we had those kinds of questions, really trying to clarify some of his philosophical views, which were sometimes not so easy. And the other thing was then philosophy of mind and cognitive science, and that's where we really started discussing, and we even had a sort of a joint project we worked for a few years. But so unfortunately he died in 92, and we never finished that project. But anyway, so afterwards I think Bohm introduced me to Basil Hiley in 1991, so that was like 1 year before he died, and I'm very lucky for that, because Basil and we hit it off rather well, and him coming from physics, mathematics, and me much more like from philosophy, so somehow we perhaps sort of complement each other, and still found some common themes. And I guess the fact that Basil was like 30 years working with Bohm, I think it of course influenced also his thinking quite a lot. So we have a lot of the common language. And so with Basil, we focused on some of the key notions Bohm and Hiley were developing. So this is one thing, is so-called Bohm theory, where it's also known as the pilot wave theory, where the radical suggestion was that the electrons are little particles accompanied by a new type of field, but it's not pushing and pulling the particle mechanically, but rather informing it. So this new notion of information was something that I got very interested in, actually already in the 80s, and that's what Basil and I have been exploring. But then there's also a much more general scheme that Bohm and Hiley started work in the 60s. The Bohm theory Bohm published in 1952, but this much more general scheme is something they call the implicate order approach. And I think in that approach, one is more not so much interested in finding out the things that exist in the universe, what are the little thingies like particles, but one is more interested in the orders, patterns, and trying to build a new language and also new mathematics to look at the world in those terms. And I think in philosophy these days, this approach would be quite close to something known as structural realism, where one feels that somehow what science and physics is doing, it's really trying to tell us what is the structure or order of the world, not so much what's the furniture, like, what are the things in it, because our views about the things seem to change quite a lot if you look in the history of science. So, people say there was the ether, but they give that up. But somehow what seems to prevail in scientific revolutions are certain relationships and structures, and so I think Bohm and Hiley started thinking in this way, that maybe order is the primary concept in physics. And I guess I could add there so what's this thing about the implicate order? Well, the idea there is that there are many situations where the whole information about the whole is contained in a very small region. So this is like, an important metaphor here is the hologram, where each part of the holographic plate contains information about the whole object. And I think this is something that Bohm realized was there in the laws of quantum mechanics. And if quantum mechanics is the fundamental description of the universe, then maybe this implicate order or this role of wholeness in some ways present in each part, and perhaps also each part in some sense sort of unfolded to the whole. These types of concepts were then central in this work.
Ah, okay. Well, I want to get into an idea that I was told about by a gentleman named David Gladstone. he's been mentioning this over and over again, and he keeps mentioning your name. He says Paavo Pylkkänen and brain as a quantum measuring device, right? And he has put this in 4 or 5 emails. So this is one of those things where, as I started to research this, I started to understand why he's so excited about it. This is an idea, actually, that, if I understand correctly, this was mentioned by Bohm and Hiley in The Undivided Universe, and they suggested that the brain is capable of manifesting and revealing aspects of the quantum world. Can you describe a little bit about what that means for us?
Well, yes, I'll give it a try. I mean, you see, of course, one thing is to ask. We can ask, what's the brain doing, you know? And of course, one very important aspect is perception. So in perception, we could at least sort of naively suppose the real world exists as a physical world, and through our senses we receive information in various ways. And so for example, the eyes, we are sensitive to the electromagnetic field, and we abstract information from there. And now you see, well, so then we can also think that in this perception, the information is then being carried to higher levels by the brain. I mean, we could say, of course, that the brain has its own model already, which it compares to the incoming information, but still the outcome is somehow being received and apprehended in conscious experience, at least in some of the time. And then once we apprehend and we realize what something means, then there's a reverse process which results in action. So there's this kind of a two-way movement all the time from, if you like, from the rather manifest external world that we're perceiving to the more subtle levels of brain and mind and consciousness. And so this is sort of a, well, this is something that Bohm also called, there's a principle he called soma significance, emphasizing how material structures carry meaning towards these higher levels. And when we perceive the meaning, there's what he called the signosomatic response, which is the way we respond. And you could say that this relates to mind and matter also, in the sense that, of course, there's a kind of a very dualistic tradition in Western philosophy, where we say that mind and matter are completely different from each other, and then we can't really understand this, how this kind of two-way movement is possible. But if we don't make the assumption that there are two separate substances, but just, let's say there's one energy which can be either rather manifest, like this object here, or more subtle, as possibly some of our energies in brain and consciousness, then we could say that the perception is a process which in a way mediates from the material world toward the mind, and then in the reverse moves, and our actions again typically bring it from mind back to matter. Or often, of course, communication is a way, you perceive something and then you communicate what you have perceived, and so on and so forth. Now you see, one thing is there, that how does this happen from the physical point of view? For example, perception. Is it all something we could describe at the level of classical physics? And I think Bohm and also Niels Bohr, they had this intuition that the brain might also be using quantum processes. This is something that's been explored by many other approaches today. But in the case of Bohm, he felt that as we are perceiving as we are getting the information from the external world and processing it, this could actually connect to the quantum level. So it could actually involve those quantum processes, and this is of course very speculative, but maybe some of the higher processes like intelligence could take place there, and then in the reverse process, whatever happens at the quantum level would be then amplified more to the macroscopic brain functions and resulting in actions. And of course, if you think about it like that, then it's a little bit like a quantum measurement, because also when you are making a quantum measurement, you have a macroscopic instrument, which also has a quantum part that can, if you like, talk to quantum objects. So I guess we are here thinking of the brain as having both this macro classically describable part, but also a kind of a quantum part, which then where some of the processes are happening. I mean, of course, some people would say the brain might be a bit like a quantum computer, but I guess here when we say that it's analogous to a measuring apparatus, we maybe want to connect to a process that we understand to some extent. Like, you know, the people have been talking about quantum measurement for a long time, and there are different theories about it. So I mean, I don't know how helpful the metaphor is, but it's still somehow trying to. It really has to do with the possibility that there is a kind of more manifest aspect and a more subtle aspect in us and in our perceptions, and that quantum mechanics might actually help us to understand how all that works.
Yeah. Well, these are big ideas, I guess. And so the way that Bohm phrased this may not make sense to a lot of the like lay people out there, but I guess maybe a more layperson's perspective would be that elements of quantum non-locality and uncertainty in the brain could potentially manifest as things that we would normally call telepathy, clairvoyance, and experiences of that nature, right? So I guess what I'm trying to do is suggest that, you know, things that we are familiar with, strange experiences that have gone unexplained in our world, could potentially be explained by these quantum events in the brain. Do you think that there's any merit to that idea?
Well, I haven't looked into that side of things so much, but I mean, I know a lot of people have been interested in that possibility. But it could even be the case that quantum mechanics might explain even the so-called ordinary brain function if some of these very speculative hypotheses are correct, in the sense that that although we usually think that everything, you know, a lot of people say that everything interesting happening in the brain would be a fairly mechanical at the level of classical physics, and it would involve things like separability. But in the Bohm approach, it's the so-called non-local quantum potential that makes this locality possible. So there's the idea that there's actually an underlying, more holistic quantum realm that makes possible for there to be this more mechanistic world that we are used to. And of course, well, it's an open question whether if that is true, then whether some of these quantum processes could be used for these kinds of things like telepathy. But I guess the current assumption is that one cannot send signals using, for example, the quantum potential in the Bohm theory. It's too fragile. And that's also the way there's no contradiction with the theory of relativity, which would say that the maximum speed for a signal would be the speed of light. Therefore, you know, if you were using the quantum potential send signals, then you would violate relativity.
Yeah, that's one of the things I guess has caused me some confusion because, like, for instance, in the case of something like telepathy, right? Potentially there could be quantum signaling there, but that would seem to involve some form of quantum entanglement. And that's been demonstrated in the lab on a particle basis, right? But I mean, not on, you know, not in a complex biological system like an entire mind. And then there's the question of how entanglement would even happen in large biological systems like that and how it would be maintained over time, right? So,
Right.
well, so I want to explore some of the mechanisms for this for a moment. You've written that retinal cells can amplify only a few quanta of light into a classical nerve signal to the brain. So it seems like that's one direct example of a quantum effect being used in our nervous system, right?
Yes, and that's been known for a long time, and you can find that even in standard neuroscience textbooks. And the idea is that there is just like there's this retinal molecule in which then a very tiny energy can cause it to change its shapes, and then these things will be amplified. So, and this all happens in 37 Celsius. So at least some, if you like, biological quantum processes take place in ordinary room temperature or on that. And then of course people say, well, if that, then I think people often say that the retina actually is part of the brain. And so if you can have this kind of amplification taking place in the retina, you could in principle have it elsewhere. So this is something that Bohm is also mentioning. And of course we have other work in quantum biology with photosynthesis and magnetoreception in birds, which is rather interesting. It's still, I mean, people will say that it's still speculative, but at least there are kind of very serious proposals and they also published in good journals. If that, it's not a criteria of truth, but it's maybe just showing that the work is taken seriously as a possibility.
Well, Stuart Hameroff proposed that microtubules in neurons could be capable of quantum processing. And I've also read that Froelich condensates could potentially be a mechanism, although I've actually read a couple of different approaches to that. I guess one group has said this, the Froelich condensates could be part of quantum processing in the brain, and others have said, again, the brain is too warm, wet, and just noisy for those to exist for any appreciable length of time. What are your thoughts on those as potential mechanisms?
Well, I think the work of Stuart Hameroff is extremely interesting. It's something he's done with Roger Penrose, and of course, I think, I first met and heard Stuart Hameroff. This was in 1994 in the first Tucson Consciousness Conference, and I think we were all watching these huge videos. He was showing the microtubules, and this is rather amazing. I think this is they were kind of launching their new approach there, and I say so. I pretty much followed the work for 30 years, and I think one amazing thing is that Stuart has got a lot of people to do experimental work. So me as a philosopher, of course, one is sometimes sort of stuck in the armchair, so to speak. I mean, it's nice to speculate about things, but then, I think part of the program, of course, we have a role, maybe try to clarify ideas and connect them to these, larger questions. But I think to see what Stuart and people around him do is amazing in the sense that they do engage a lot of experimental work. I think he's inspired a great number of people work at very different aspects of the program. So I'm still, I would say I'm rather optimistic, and something rather exciting might come out of the work. I mean, there's already a lot of interesting things, but somehow it's also extremely interesting from the philosophy of science perspective, because that's one, I teach courses in philosophy of science, and there we discuss things about, how does science work? How should it work? People say we should make bold proposals. So, Penrose and Hameroff are certainly an example of people who try to do this. And then you have people trying to falsify it, and then they usually, they come back. So there's a kind of, it's rather interesting in many different dimensions. And you mentioned the Froelich condensate. So that's another idea. I think Froelich realized in 1968 that in a biological system, if you pump energy into it, this can give rise to certain kind of, I suppose you could call them macroscopic, but still these quantum coherent states. And a lot of people have been interested in it. And recently there are some groups, like I think in 2015, there's a group in Gothenburg where they say they actually managed to give rise to a Froelich state in a molecule. And now some critical research say that it's you can't have that in the brain, and therefore it won't serve the Penrose-Hameroff theory. They would need something else, but I don't know. Other people have suggested that you might be able to have, so that could be one of those open questions. And I know there are some research groups who really are looking into that. So that could definitely be one possibility.
Well, this is really exciting, because if a connection like this exists, and I think from what you've been saying, if I've interpreted this correctly, part of the information processing in the brain could actually be taking place outside of the brain, right? This was kind of the differentiation between brain and mind. So brain is kind of like this biological computer in a sense with synapses, and then mind was connected to this larger quantum information manifold, as it were. Is that close, I guess?
Well, it's interesting the way of putting it. I mean, I haven't thought about it in quite those terms. I mean, this is, I guess, one distinction that might be useful here is the distinction between implicate order and explicate order, where explicate order refers to the order of things in space, and then whereas implicate order could be more, it's a kind of an processes that are connected to these physical objects, but not necessarily existing in space in the same way. So, for example, in this already in the Bohm 52 theory, it postulates that an electron is a particle which is accompanied by this wave. For a single particle, we can think of this wave as living in three-dimensional space. But already for two entangled particles, this wave lives in a so-called configuration space, which is six-dimensional. So you have to always have three dimensions when you bring in a new particle. And this is something that philosophers even today are actually rather puzzled about. How should we interpret this thing? Now Bohm suggested that this quantum field could be a kind of field of information. So maybe we could then think about the mind as existing in some sort of information space, which is nevertheless intimately coupled with objects in three-dimensional space. So this informational space should become something we could call it's like kind of an implicate order. It's not in space, but it's still very closely associated. Like in our case, our consciousness, our minds our thoughts, they are intimately connected with our brains, but perhaps they need not be completely reducible to physical objects in the brain, but they're somehow, just like in quantum mechanics, I mean, this is just an analogy, but just like in quantum mechanics, we have a particle and a field, where the particle is in three space, and the field could be has a more subtle existence. The same could apply for our minds and our brains, our bodies.
Do you think this might be a shared space? And the reason I ask is ancient cultures have written about something called the Akashic records. And Dr. Bernard Beitman is also working on a model for telepathy and things like that that's similar. If the mind is part of a larger space, do you think that could be a group or shared space? Do you think that could potentially allow these interactions that people have reported? Or is that just a speculative bridge too far?
Well, it's again something, how would you say? I mean, even the philosophers who sometimes take a very, I don't know, humble or mundane approach, they're not necessarily looking for anything terribly exotic. But I think in philosophy, people talk about collective intentionality, shared mental states, and perhaps even shared consciousness. And they don't, I think, they typically want to keep things very down to earth. So whenever these things are brought up, one is still feeling that there's a sense in which we could explain everything in the safe and familiar, interaction between people. But I think this kind of idea is still there, and a lot of people are interested in it's in the field of social ontology. Now, of course, I mean, you could, if you bring in something like quantum mechanics, of course, that does open up these maybe a bit more radical possibilities. But then, of course, one trouble there is to test these ideas and test these states. I know some people are trying to do that, but still, I mean, it's not always that simple to do it. But of course, you could say in another way, you could say that our culture is shared meaning, and of course, in some ways, in a trivial or mundane sense, our experience is very, to a large extent, shared. Even so-called ordinary communication, and when one thinks about it, even that can be exotic in its own way. That the way culture affects all of us, and in that sense, the fact that it's shared meaning, it means that we are really not at all as separate as we may perhaps usually think we are.
Well, that's a really important point. There are so many conventional explanations that I guess hint at these things. And I know these are incredibly challenging questions, because nobody really has the answers to them. But it is intriguing. A lot of the past interviews that I've done in consciousness seem to indicate that there's something more to the human experience. And I think on some level, most of us, or maybe all of us, feel that way. So then it becomes this question of, what are some of the potential mechanisms that might lead us there? And I wondered if Bohm's work, definitely your work as well, with the brain as a quantum measuring device, that could potentially explain some of it.
Well, yes, I think yes, I think that's one avenue. I guess in philosophy we are even puzzled by questions like, how is my mind connected to my brain? Like, even that, sometimes that's called, like, there's an explanatory gap there, or it's difficult to understand. It's difficult to understand. You see, suppose it looks like my mental states are mental in some sense, that they're not physical. But if I say that, it's very difficult to understand how something non-physical could influence the physical. People would say their energy conservation of energy and other things like that. So we are even in philosophy, we are still struggling to understand how the mental and the physical are related. And perhaps that's one of the reasons why people are not so trying to tackle these, in some ways, even more difficult questions about the more exotic possibilities about that we mentioned here, which kind of doesn't mean. But it could well be the case that if we one day understand the relationship of mind and matter better, perhaps by making use of some quantum mechanism, that might well open us up a way of approaching some of these other questions and problems that people are interested in.
Absolutely. Well, speaking more practically, if the mind is semi-independent of the brain, and again, this goes back to things that you'd written to me earlier, would that suggest, I guess, that even in just a processing and perceptual sense, we have greater capabilities than traditional neuroscience assumes?
Well, yes, I think it could be. I mean, I guess, of course, maybe neuroscience is not always so concerned about our the limits of our processing or perceptual or things like intelligence. But there's always, I find there's always a danger in modern science or cognitive science, where we often work with very mechanistic models, whether in computational models or in neurophysiological models, that there can be kind of a sudden, what I mean is like a hidden effect, in the sense that we tend to mechanize ourselves, and if we use those models as models of ourselves, they may become like limiting, because there is the other view, is that actually the human mind is infinitely complex, but even the physical world might be infinitely complex. And that really means, if that is true, then it gives us possibilities for creativity that are perhaps much stronger than is commonly assumed. And this is where I feel that this is the danger with so-called traditional cognitive science, traditional neuroscience, that we accept too simplistic mechanistic models. We assume that everything is finite, and somehow and we our ideas about creativity can be rather mechanical or limited, and that's where I feel that it's a better working hypothesis to assume that the human mind actually has capacities that we do not yet understand, and perhaps hopefully explore them, and then of course use them if we can tap into it, so to speak.
Well, on that note, Pavo, let me thank you so much for your time today. And let me close by asking, how is the research progressing in understanding, testing, and really fully, I guess, fleshing out where consciousness is going? Do you see anything coming in the near future that may help us continue to better understand what's going on here?
Well, I think there are, I mean, right now, as we're talking, there'll be this spring, there'll 2 conferences. There's the Science of Consciousness conference in Taormina, Italy, And there's another one in New York in June, the Association for the Scientific Study of Consciousness. So we have we have hundreds of brilliant people, philosophers, neuroscientists from many other fields, really trying to think about this problem. And this has now been going on for maybe like 30 years. So I mean, definitely there are possibilities there. But I also think still it may be that some new ideas are needed, and we have to be kind of bold if we are going to make progress. But I do feel that the field is sort of open-minded, and people are really exploring these different possibilities. So I'm still looking forward to seeing what might come out of it, let's say in the next 5, 10, 15 years.
Wonderful. Thank you again so much for your time today, sir.
Thank you. Thanks.